So GM everybody. This class is about advanced Starknet smart contract development. So from what I believe, you have already been introduced to Starknet and Cairo programming language. So here, our mission is to build upon what you have been taught so far and learn something about advanced stuff that you can do writing writing Starknet smart contracts. Before I get started, I am Abubakar Abatunde Lawal, popularly known as Utility. So I'm the co-founder of Fundable Finance. You can find me on Twitter, Utility6151, and that is me on the screen in case the video here is not clear enough. That is me on the screen, and I'm pleased and honored to be taking you through this particular session. So what we'll be doing today is that we'll look at today's agenda. What are components? So the properties of components, Cairo component, composability, the syntax itself. Then we do token sale contracts. And at the end of the session, you'll be given take-homes that you are going to work on. So what are components? My mental model for components usually revolve around the fact that everything that needed to be built cannot be built by itself, in and of itself. So there are so many things that need to be combined before we can have a final product for a lot of life concepts. Let's take a car, for example. The car is not just the car that we are driving around. It's made of different components. The engine, the car seat, the tire, body, and what have you. So these components are made differently, but combined together, they became a product, and that product is the car. So when we talk about components, we are talking about bringing different individual or standalone concepts together to form another entirely new product. And I used to say it a lot that blockchain in itself is not a novel technology. It is a novel technology because of the combination of different existing technologies. If there is nothing like cryptography, before Satoshi started writing Bitcoin white paper, there will be no basis for encryption. If there is nothing like distributed system already existing in the world, before that, there will be no basis for Bitcoin. So Bitcoin leverages decentralized distributed system, leverages cryptography, leverages peer-to-peer mechanisms, and these composable components hacked together formed the basis for blockchain. So blockchain in itself cannot just exist without these pre-existing components. So that is exactly what component is about. Like we bring together different pre-existing stuff to form an entirely new product. Do you get that mental model now? Awesome. So component is just like we pick different things together, we join them together, and then we make it to form an entirely new product. So this is just what I've just talked about. What a component is basically, okay, human body, trillions of biological components keeping you alive, different system working individually, but making you a combined human being. I made an example of the vehicle earlier. So what are the properties of a component? So the component should have the following properties. Number one is reusable. When I mentioned car earlier on, let's assume the headlight of a car. So the moment a car has an accident and the car is unable to move anymore, you will realize that the plant takers will come around and start dismantling it. So they will remove the headlights to be resold to another vehicle, meaning that that component, headlight, is reusable. So they can use it for another vehicle of the same model, and it is also interoperable. Interoperable means that sometimes you go to the market to buy headlights, they tell you that the particular model of your car is not available, or there's another model for another car that can work for yours. Meaning that it is not only restricted to that particular model that it can work for, it can also work for another model entirely. So it is interoperable. It is also simple. Component in itself should not be complicated. The end product can be complicated, but the component shouldn't be complicated. Imagine if they have to make headlights and they make it so that the headlight can adjust to light in itself. Like, it is daytime, shut down. It is nighttime, shut off. Not that there is another component that is controlling that. So each of the components should be simple as much as possible, and they operate, work along with other components. So yes, that is the component, that's the properties of component. Component has to be reusable, it has to be interoperable, it has to be simple, and it should be able to cooperate with other components. So this mental model will keep you abreast of anything you need to know about Cairo, or let me say Starknet components, because you realize, oh, the essence of us actually having component is that independent of the smart contract itself, we can still use this component in some other contracts. For example, you are writing a smart contract about token sales and you need ERC20 token. Instead of you hard coding the ERC20 coding logic into that particular contract, you can actually build a standalone ERC20 component that allows you to use it in the token sale contract, allow you to use it in another contract, maybe a distribution contract, allow you to use it in a voting contract, allow you to use it in a pool contract, meaning that this same ERC20 contract can be used in different other contracts. So this ERC20 contract, as I'm calling it, is a component that is reusable. So yes, it is more of a Lego block, or you combine them to build an output. So what is a Cairo component? I have already dived into that before even getting to the slide. So Cairo component is like a smart contract, but not a smart contract because it is not recognized by the Cairo VM as a complete smart contract. It should be part of another smart contract. So we'll get to what differentiates a component from a normal smart contract. So let's take it slowly so that we don't jump ahead of ourselves. So far, is there anyone who has a question? Anyone? I like my class being interactive. Anyone? Or okay,
Oh,
just tell me what you understand by component in your own words. Clement, go on. Yes, we can hear you.
okay. According to my own understanding, a component is a reusable block of like smart contract logics that can be used, and like it can be actually reused anytime you want it to make up a full project.
Interesting. So, what will you consider a component
Is
in
the
your
question for
contract?
me?
Yeah, the question is for you. We are still interacting in your contract. So, if you need to write a contract and you want to use a component, what do you think? Okay, so far that you've been taught about Cairo, there could be some part of it that you feel like, oh, this is actually reusable elsewhere, not only part of the contract.
I think ERC20 we can import it from Open Zeppelin.
Interesting. Yes, that's correct. So yes, that is actually the idea of a component, something that is reusable. You can take it to some other contracts, not hard coded into the immediate contract. Anybody else?
Yeah, just like you said, components are just ideally to be parts of code that instead of putting everything combined in one code block, you can have them in separate places and then you use them when you need them. So let's say, for example, uh, your modifiers, things, restrictions that you need in your contracts, you can have them separately. And then anytime you need to restrict access or you need to make something ownable, you can just import those block codes into that contract.
Perfect. So imagine you need access control in your smart contract, and you want to grant different people access based on different rules. So that particular feature can be used for almost every contract existing today. Meaning that if we all have to be coding it into our contract all the time, we are just wasting human effort. Why not just write one that is well vetted and all of us just bring it into scope at the moment we are about to write our contract? Yes, that is perfect too. So let's continue. So as two of you mentioned, the RC20 component and the Honeyball component by OpenZeppelin are actually an example of a Cairo component. So, and they are the most popular. We will use them later when we are coding. So what is the benefit of a component-based development? Number one is code reuse. You both mentioned we can use them anywhere. There's no need for us to rewrite them all the time. Number two is security. Most of them are battle tested because if all of us agree that we want to be using them, then that means there are several eyes looking at the logic of that particular component. And most time, components to be used that are public are majorly audited. So almost all the time when I want to use component, I use OpenZeppelin component because I am actually very confident in the code that OpenZeppelin writes. They are mostly audited. The maintainability too. So imagine all of us are writing our access control differently in our smart contracts, meaning that if we all need to maintain that particular access control, we need to all modify our contract at the same time. But instead, if it is one source of truth, so we only need to modify the one source of truth and everybody have the updated code. So modularity, it is modular. We can take it anywhere. It is just like a building block. So we can build it from from complex contracts to simple contracts. It is just that faster development. When we get to coding, we realize that, oh, if we are to implement all of this ownable logic ourselves, all of this ERC20 logic ourselves, it will take longer developmental time than actually bringing the component into scope. The other thing is consistency, because we are importing, because we are bringing ownable component into scope, every module or function that we'll be calling inside the ownable contract is actually going to be consistent with every other person using the same component. So it is not like I have different function in my ownable component, you have different function in your ownable component. As long as we are both bringing the same component into scope, we have consistency of patterns all over. So yeah, that is a benefit of using a composable smart contract. So yeah, the end goal is to show how the component makes Cairo programming so much easier, even for complex functionality. In the coding session, we'll combine ERC20, reentrance guard, Honeyball to create a simple token sale contract. So how do we recognize a composable, or let me say component in Starknet? Let me use this structure. How do we recognize a component? Okay, this is kind of blank. Open Zeppelin. So Open Zeppelin actually has a lot of components that we can use in our contracts. So once you come to this particular repository, under packages, you have access, account, finance, governance, interface, introspection, macros, macro tree, presets, security, test command. All of this can actually be used as a composable contract in your code. So how do you recognize a composable component in Starknet? It starts with this external attributes. So there's a difference between a contract and a component. Let me see if I have something relating to that. Okay. Okay. But let me issues. Just want to differentiate between a component and the contract. I know all of you actually know this already because you've been introduced to Starknet. programs for the past 2 or 3 sessions. So let's say this is a contract. You can see the external attribute is different from what we have here. The attribute here is starknet.component, while the attribute here is what? Starknet.contract. So this differentiates these two modules. One is a component and the other one is a contract. So that's basically one way to differentiate between both of so yeah. So you define each component in its own module denoted by Starknet component. This is how you recognize, oh, once you see this, you know that that particular module or code is a component, not a smart contract. Also, when you are going inside, you define the component interface. The component interface is the same thing as the interface of a smart contract. You only highlight all the functions you want to implement and you want to be publicly available for users to be able to use in your smart contract. So, for example, the ERC20 component allows you to actually use total supply, balance of allowance, transfer from, and approve. So you do that, the same thing, there's no difference here. The same way you do the interface for your smart contract is the same way you do the interface for the component. Once you actually do that and you want to start implementing the logic of the component, you use your implement block by making it as embeddable. This as embeddable means that once you try to use it in your contract, so the embedded as is actually where you get this particular name. Like, okay, what does this embedded have? What was it embedded had in the particular component? So if we are going to use the ERC20 component and we want to bring this particular and then implementation into scope, this is what we use. How you are going to import it into scope. ERC20 implementation of contract state. This embedded as is telling you, okay, this is what is publicly available and how you are going to bring it into your scope. And then once you actually do that for your publicly available functions, for the internally available functions that will not be exposed to the users, this is how you go about it. So you omit the embeddable as name and just add the generative traits, public implement, and this. So what this does is that it is only the contract that is actually using the component that can call this function. It will not be available to the users of your smart contract. Is that understood? So step by step of embedding a component into your contract, we'll actually do this in real time once we get to the coding part, but I just want to go over the steps. So the first one is that you had the component dependency. Let me come back here. Component dependency in your scarp.toml. So this tells you this is the component you want to use. This is showing us that we imported OpenZeppelin component. We imported OpenZeppelin component into the scope of this particular contract or project. Then you import the component. You import the component inside the contract that you want to use it in. So assuming I want to use it here, I brought in, where is this again? OpenZeppelin enable component. This is the importing of the component into the scope. So you declare the component by using the component macro to declare which component you want to use. And this is basically what is done here. So this particular macro takes three arguments. The first one is the path. Where is the part of the component? What is the component going to be called in storage? How are you going to use it inside your smart contract? And what about the event to be emitted by the component? So you look at this, you say, okay, part is the upgradable component itself. here. This is the part. This is the part, the upgradable component. How about storage? Storage is the upgradable. Look at it, storage here, upgradable. We'll get to all of these technicalities, or let me say all of these syntaxes once we start writing the code. And then the events. So you also declare the event, upgradable event in your event section. So upgradable event, this is what it looks like in your event section. Without three of these, you will not be able to bring this component into the scope of your smart contracts. So you add the component storage to your smart contract structs. Done that already. Look at how it looks here. For the upgradable, this is your smart contract storage struct. The upgradable is brought into the storage. You include the component event in your contract event enum, expose internal functions, and then you use the external functions and use the internal functions. So we'll get into all of this the moment we get to coding in real time. So before I continue, is there any question? Is there anything unclear? So we are going to currently jump on a token share contract. And for the session, what we are going to be doing is a simple contract similar to an ICO, where you send in a certain amount of token A to get out a predetermined amount of token B. So meaning that we are going to do a fixed exchange rate. So we implement a simple buy function where you send the token A to get the token B. It is going to be controlled by somebody who can set rate, who can withdraw the token A that you used to buy the token B, and as well withdraw the remaining token B from the smart contract. The contract will use a reentrancy component to prevent reentrancy security risk, and we are going to use access control for the owner to be able to set rate and do all of this other similar stuff. So I think it's about time we do the actual coding. Anybody here? Should we proceed? Would you be coding along? Or I should go on and code? Yeah, is there any question at all? Let's talk. Any question? Somebody should say something.
No question for now, sir.
All right. So let's go to all right. So this. Can you also see my screen? Stop me. Okay, says. Okay. So okay. For this one, awesome. So yeah, this is our workspace. About terminal hub. There's no need for me going through all of this. You have already been introduced to it. The structure of a Starknet project, the file structure, you have the source, you have the test. Usually it comes with already with a pre-existing code. So most of the time when I do this, I want to know whether everything works well. My first building. Let's see. Okay, everything was fine. What about the test? Mm. Test works through. That's all interesting. So, but yeah, we do not need any of this, so take it out. We also do not need the tests, we'll take it out too. For our token sales contract, we will definitely need 2 tokens to be able to exchange for one for the other. That means we need a token A, we need a token B, and we also need the smart contract of the token itself. All right. So in this instance, I think it's safe for us to do safe for us to do, let's say node blocks node token. So then we create the 2 files. And so that file as well as so this forms the basis of what we want to work on, the mock tokens, and then the token sales themselves. So for the mock tokens, we need token A and token B. So meaning we say not token A for token B. And then we create a folder for the mocks. And inside we create token A file as well as token B. But so we have our tokens. Let's see. Good. Okay. We have our functions highlighted for us. Let's start with the token contract itself. So for the token contract, we need to declare the interface that we want the users to be able to interact with. So for our interface, what do we need here? Can anybody bring suggestions of the functions that we should expose our users to? Interface.
Transfer.
Say, I'm with you.
The
Someone say
functions.
something.
Yeah, you were asking of the functions. So I was also suggesting maybe
Yeah.
it's transfer from, like, because we are definitely doing something like swap.
Yes, transfer from, since we are doing something like swap. But don't forget, this is yeah, it is swap, but I prefer the buy and sell because it is 1 for 1. You send in a certain amount of token A to getting a predetermined rate of token B. So let us assume we say, okay, for the rate is 100. If you send in token A, 1 token A, you get 100 of token B. So that means you are buying with 1 token A, and what you are getting back in return is 100 token B. So yeah, I think that also works, but I think buy and sell actually sounds better for our situation. So let's turn our attributes. Calculate go to interface. So we say attribute attribute by token so going to be applying that so we need the buy token function by tokens. It's definitely going to be modifying states. So how do we differentiate a state modifying function from one that is not modifying state? Can anyone hear me? This is just like a revision of what you have done so far in the previous classes. So how do you differentiate a state modifying function from one that's not modifying state? Can anyone help me out on that? Hello, hello. Anybody here?
You declare them as view or pure.
Hmm?
You declare them as view or pure. Non-modifying states are represented as view or pure function.
Sorry, I didn't get that. Non-modifying state function are represented with what?
Yeah, view or pure. Since the only thing you do is just read.
Yes. So how does the function signature look like? So basically, maybe my question is not clear enough, right?
I don't know, function, the name of the function, then its access modifier, public view. Is that not what you mean?
Okay, yes, that is actually correct for solidity. For Cairo, how do you know if by looking at the function signature of a function, how do you know if it is a modifying state function, a state modifying function, or non-state modifying function?
So I think the ref keyword would
The ref
tell
keyword stands for
for reference. So it's telling you that you're passing or it's going to tell Cairo that this is going to modify, is going to allow for modifying states. So
awesome.
you can
Awesome, yeah. That is exactly what I'm looking for. The ref self is what differentiates a state modifying function from a non-state modifying function. So let alone we want to now get to it. So what is the rate we are selling this? We say, okay, no. And then we use what is known as a span. Span means we are copying states, not that we are modifying it. Okay, so if we get to it here. So you do 56. Control state. What did we go? The control state. Okay. So yeah, that is the differentiating factor. This one is actually a non-state modifying function, while the ref of is a state modifying function. So what test should we be exposing to the users? Let's say function gets token out. So how much will you get once a particular, just like a calculator? So if I send 2 tokens of token A, how much of token B will I get back in return? And it is basically a non-state modifying function. You can trust it, and then the amount to be sent to me. This is 56. So what other function do you need? Okay, function withdraw payment token. This is only a function for the owner to be able to withdraw the amount that they have in the contract that is from the payment token here. So how much do you want to withdraw? 26. We can as well expose another function that withdraws all. Withdraw all units token. So how about withdraw set token? Okay. So, keep on track. Withdraw all of the so what other function do you need? Okay, we got rate, we did not set rates. Function set rate. So so let's leave it for now. So once we get back to once we are in the implementation block of the smart contracts, if there's any other thing we need to expose, we'll come back to the interface. I'll go to start unit with contracts. Start a new contract. And okay. Yeah, so let's do reports. Let's do components initialization. Knowledge. Events. Let's do contractor. Storage. And access. And constructor. Constructor. For the storage. Okay. storage period. At any point in time where anything is unclear, please let me know. So for the imports, since we will be using storage, it is important that we first bring in the storage fields from Starknet. Storage. Storage access. Storage access. We'll definitely be using address tool. Or since it is above this footer and internet address. We'll be using the caller address. Use that note. Good caller address. Good caller address. I'll also be using the token zeros. Let's speak for so for, as I mentioned earlier, we need two tokens, and as well, we are going to use the entrance fee and the enable component from the open zeppelin. So one thing we need to do here is bring it into scope by adding it to our dependency. Once you bring in a new dependency, you try to check if it's built. All right, everything works fine. In our publicly available function, I think we should also initialize, we should have an initialize function that tells us that, okay, maybe this should be done or not. Initialize of the control state. Actually, die. Okay. Yes. Okay. Contract address. The contract states. All right, since we already have the open zeppelin in scope now, we will do open zeppelin. So once you have decided to use a component, the best thing to do is to go to the component repository and get familiar with the internal and external functions exposed from the repository. We want to use the enable component as mentioned. So where is the enable component? Enable component is an access package of OpenZeppelin. Let me go back. Access. Some assets we have the enable, and what is the name of the component itself? Enable component. The component. We also want to use reentrancy. Let's say use that. Yes, where's reentrancy located? It's located in security. 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 And reentrancy guard. And then say guard. Reentrancy guard component. Reentrancy guard component. We also need the interface for ERC20. Use that name slash interfaces IRC20 security dispatcher and IRC20 dispatcher with interfaces. Yeah, interfaces. Interfaces token. Interface. Oh, that's it. Not publicly available. Security. Yeah, security dispatcher. IRC20 and it's not possible. Securities. And yeah, security start chat root and start chat and finally find this out fast. The compiler is invalidated. Anyway, let's continue. So component initialization, you need the component macro. So for the component macro, we mentioned earlier that we need the parts. We're going to be we want to initialize our enable component. Enable component. We need the storage. What are we going to call it a storage? Call it enable. Enable, and then the event. Call it enable event. Yeah, security, management of funds. Basically, to structure to okay. Yeah, sometimes. So yeah, I mentioned that we are going to initialize the component. I initially just wanted to check what this squiggly line is telling us. Compiler is not seeing it every time. Meanwhile, there's no error with it. So let's continue. Let's say sub storage. Sub storage is version 0. Sub storage version 0. And then our enable. For example, it's equals to enable component and storage. The storage. So for the storage of enable, then the event. Event. Network. Supplement. Event. Event. Mostly. Is anybody following? Is there any question before I continue? Any question? Let's type of component. Does this look like magic? Anyone here?
With you.
Yeah, me too. Let's build and see what's up. Okay. Inline macro event not found. Inline macro event not found. Inline macro event. Oops. Yeah. Command output where it is supposed to be can cause a problem. Okay, so everything was signed up onto this period. How about our entrance guard? Component. Our parts, which is entrance guard, it again, the entrance guard component. Component. The entrance guard component. The storage, what are we going to refer to? Let's see, let's call it the entrance guard. And then the event. Entrance guard event. I'll do the same thing for this in storage. For storage, reach 0. Variant guard. Guard is entrance guard component reach. As well as we go to the event, the entrance guard event. Guard event is entrance guard component event. So this is basically how we are going to bring our component into scope, and that is what I have been doing. Then, now that we have the component, how are we going to access the component? So this is where our implementation comes into play. So the component that we want to bring into scope and we want users of our contract to be able to use, we use the API embed of the barrel. Currently, we want to expose functions, public functions from our holdable component. Do that by going here, looking for the assets databases. The functions we want to expose out to our users from our components via our contract, we target an external attribute ABI embed version 0, and then we say implement enable implementation, enable implement equals to enable components, or assigned to enable components component. I believe go back to the code. Let's do it again. So when I was talking about embeddable hash, this is how we are actually going to bring all of the scope, all of the functions in the scope of this ownable component into the scope of our contracts. So once you see embeddable hash, and where you want to actually expose the functions in your contract, you use the name of the embeddable hash. Ownable, maybe what again? Ownable implement. So you give it your contract states. Right. Well, once it is, you still want to be able to access the internal functions of this particular component in your contract. So this one does not fall under the ABI.embed. And as I mentioned earlier, the internal functions are basically just annotated with generative traits. So these are the internal functions of this particular composable contract or component. So we come here and we say implement enable internal implementation, internal implementation, enable components, and internal implementation. I think implementation is internal implementation. Internal implementation. Let's make it the contrast it. Our entrances that we are bringing into scope entrance security. Yes. Is anybody following? Is it getting complicated? So the essence of this live code is to show us how to actually use components in our smart contracts. So what we are doing here is like we want to leverage the vetted enable component, the vetted the entrance guard of OpenZeppelin and make use of them in our token sale contracts. If you look at the entrance component at the moment, you will notice that there is no publicly available functions, meaning that all of the functions or the implementation for the entrance are internals. So meaning even when we bring them into scope, none of our users will be able to access any of the functions of the entrance. So that's why it is not under the ABI embed annotation. It is going to be an internal implementation. Translate that internal implementation equals to translate that component contrast rates. And translate that the component here. Oh, I've made a lot of mistake. Same here. Right. Okay, everything works well until now. So now our constructor. What do we want to initialize in the constructor? Let's see. You all have an idea of what a constructor is, right? Can anybody tell me what a constructor is in the context of smart contracts? Anybody? Oh,
So,
wait.
simply say constructors are they are used to initialize states, but they only run once the contract is deployed on deployment. So they just set your ready to use states that should be part of the contract upon deployment. I don't know if that is simple enough.
Yes. Upon the deployment of your smart contract, you basically want to initialize some values before the smart contract is accessible. That is what your constructor is for. It can only be run once, and once that is done, you can never access the constructor anymore. So yes, let's contrast it. Contrast it. What do we need? We need the owner of the contract on contract details and it is the so we want to initialize our enable component by saying self dot enable initialize this is where the enable is coming from. So we use the enable here, and then we initialize the constructor to give ownership of the contracts to the deployer of the smart contracts. Is that understood? Is that understood? Anybody with me? Okay. Let's go on. Okay. So, what about our own custom functions? So this is where we are going to implement all of the functions inside our interface. So we come here, we see to be API embed. So implement, what are we implementing? Implement token zero, implementation of high token token zero. And then we continue with the implementation. With all of our functions, now from here, can be built into the scope here. Let's copy everything here, and then now write body for each of the functions. So our initialize function is first needs to so why the essence of this initialize is to actually initialize the contract, the sell token, and then the buy token. So with the address, we want to be able to use USDC to buy stack. So the buy token is USDC, the sell token is the stack. So this is where we actually now confirm which token are we using as the buy token and which token are we using as the sell token. But we should only be able to do this if we are the owner of the smart contracts. Is that okay? Is anyone following me? Assert.
So we're following.
Also. Assert self dot available. So what are the functions available to be called under the available public functions access? Available. Okay, these are the publicly available functions: owner, transfer ownership, and then renounce ownership. What about the internal functions? In the internal function, we have assert only owner. So let's say self dot dot assert owner. Assert only owner. So assert only owner, and once we do this, we assert if the person calling this particular function is not the owner, we want to be able to give them an error. It says only owner can initialize. So once we have asserted that the person calling this contract is the owner, we go on and set our storage. But we do not have the storage yet, so we need to come here and say buy token, which is a type of contract address. So token, also a type of contract address. So come back and say, since we have done that, the self dot buy token dot write, but we give it the buy token function argument. Into the self dot sell token dot write. The cells option cell token argument. We in the constructor and the function again, I think we have one boolean one here. So before we can sell or buy token, most time we may be buying while these particular functions have not been called. This initialized function has not been called. How do we know if it has been initialized or not? Let's have a storage value or storage variable called initialized, which is a kind of output. So upon deploying the contract, let's set it to false. That's right, false. And once this function is actually called, it will self dot initialize dot write. We change it to true. for now, okay, so for now, we also want to be able to emit an event that tells us that, yep, this particular contract has been initialized. Let's say to derive drop and Starknet event. I want to be able to move fast because we only have 1 hour left. Alright, so we call it say it is throughout. What should we call it? Throughout initialized. Initialized. Very quickly. Control yes. So quickly. Control yes. So in our event, we had it here. Initialized. Initialized is the type of initialized. Is that understood? Okay, that's the one. So inside this, we just need to admit that we have initialized the payment. So yeah. So okay, so dot emit. What are we emitting? Event dot initialized and initialized. Initialized and let's say initialized what like looking and so looking. So what we are doing here basically is to emit an event. Once these functions have been called successfully, we emit an event that yeah, we have initialized this particular token. So let's leave it like that. What about buy token? Anybody can call buy token, so there's no need for us to do ownership control. So let's just say let's check if the contract has been initialized. But image. Yeah, not initialize is perfect. Also, after we do that, what should we check again? We should also assert that rate is greater than 0. Okay. Yeah, we did not assign the rate yet. So we need rate. Rate, which is type of rate 56. We can set the rate through the constructor at the beginning, and we can also write rate 56. So yeah, let us set it. We should only be setting it upon initialization. upon initialization. So yeah, let's come here in initialization. Let's see rates. The type of 256. So we have done all of this. We have dot rate dot right. So pass the rates. Okay, to differentiate and yeah, it's telling me that you do not have rates inside there. Right. This is okay. Oh, initialize. Initialize. Contrast it. Yeah, I'm using contrast rate. It's, yeah, using the contrast type, not the generic type. I'm using a contrast type there. Exactly, on a typically set rate. Let's put our contract to compare it first. This will not build. This will not build. Couple of this will not work yet until you get to the implementation. So here, get rate equals to so dot rate. Set that enable dot assets and no. Okay, as well as to actually assets here. It's just call the function. That's not good. Then we want right. Mm, mm, To be sure, we pass to here. Awesome. Yeah. So just wanted to confirm that everything works well first before we continue. So yeah, our buy token, we want to be sure that rate is not zero. We also want to be sure that the amount that the user is passing is also not zero. Set amount is greater than zero. So amount greater than zero. Zero. Do you understand why I'm actually doing this error message? Can anyone tell me the reason for this error message?
So that we can always be sure that the exchange rate is uh, greater than zero. So there is actually an exchange rate since we are just changing value for value.
Exactly. And if the person is actually sending zero amount of token, once the function reverts, which is going to revert because if this condition does not get fulfilled, we are going to revert with this error message. And this error message is going to tell him that, oh, what you sent, the rate of at the moment is less than or equals to zero, which means it must be more than zero. So yeah, that's the essence of the error message. So what is the rate? So what do we do here now? Let's by token amount equals to amount times rate times rate. So once we have that, let's say let's show token contract equals to high reactive 20 times into dispatcher. So we give it the entrance address, which is the token rate. So that is for the shell token contract. Shell token contract. Yes, we come to dispatcher. Yeah. Okay. So what do we do next? We have initialized the contract, which is where the contract we are going to be calling. So what do we do now is that, okay, we have asserted. We also want to make sure that this user does not do what is known as reentrancy and drain our shell token amount. So we are going to do shelf dot reentrancy guard dot stats. I think it is stats. Let's confirm. So for our reentrancy guard, you can see how we are interacting with the component, right? So yes, we have the stats. The reentrancy guard dot stats. We start here. Every of the actual logic that works here into the entrance guard.h. So meaning that I don't know if you have been taught about reentrancy attack vector. Reentrancy attack vector is a situation where an attacker actually tries to drain our contracts of token in a single call. What happens is that they do not allow the contract to finish uploading states. So they bombard it before the function actually finish calling. So for example, now, instead of them to be able to send this amount multiple times to be able to buy the rates, instead they send this amount once, and this amount only come here, send with the same amount. So they can use 1 naira to buy 100 units. And that same 1 naira will be able to buy 100 units multiple times. Instead of them sending 1 naira multiple times, they are going to use just one to buy the 100 units multiple times. That is known as a reentrancy attack. So what we are guiding against here is we do not want it to happen. So that's why we are wrapping our actual logic in the start and end. Are you following? So we already have that. And the next thing to do so what's the next logic we need here? The next logic should be the actual token transfer. Should we be token transfer at this point? Or uh, since the user is actually going to be buying with a particular token, one of the things we need to do is to first transfer from their own token. Let's say let's buy token contract goes to high here, see 20 is better. We initialize the contract address. It is ourselves dot buy token. So we have the buy token too. So let's transfer from them. Transfer from user contract. So what we'll do now is buy token contracts. Transfer from. Do you know where this transfer from is coming from?
From the ERC20.
Exactly, from the ERC20 that we initialized here. So we transfer. Who are we transferring from? The caller. Get caller address. Did we bring get caller address into scope? Yes, we did. What about we also need contract address. We also need get contract address. So this is the from, this is the to, get contract address, and then the amount. So we have successfully transfer from them. Let me see, transfer from. Yep, just the argument is required. So here we have the caller address, which is the from, this is the to, and this is the amount. So once we have verified that, we transfer to the user. So we say sell token contracts. Transfer get. Okay, so instead of repeating myself multiple times, I can also just initialize caller here. So it is variable that get caller address. So yeah, we remove this, we call it caller. And the same thing here, we call it caller. And then we say buy token amount. I think this is ambiguous. We can call it amount to receive or amount to sell. Amount to sell. Amount to sell. Do you know the difference between the transfer from and transfer? Anyone? Is there anyone who wants to help on that?
So, transfer from is basically another should I say another person making the transfer on behalf of the holder of the token. Then transfer is a direct transfer by the holder of the token.
Exactly. So in this instance, the contract is the one transferring to the caller. So it is the one calling its own balance of ERC20 directly. But here, the contract is trying to transfer from the user to itself. So, and the user is the one that has the balance from this buy token contract address. So they transfer from the caller to themselves and the amount to actually transfer. So now let's emit events. We currently do not have the event, so we have to add another event. Let's say, okay, derive drop Starknet event start start. Want to buy token be efficient? Who bought token? Buy token, sell token. When people buy from our contracts, what do you think we should name the event? I'm looking forward that will be straightforward, not ambiguous. Should we just buy tokens or tokens sold? Let's use buy tokens. So who bought the caller? Contract address, amount spent, 256, items, 256. Okay. Please stop the recording. Noise recording. Stop recording. Make sure it is from me. Make sure I'm the one that can stop that. Okay, U256. Then the amount received. The sold amount is also U256. We had that to our contract, our event, buy tokens. It's a type of buy tokens. And so here we have it. Concept dot emit event buy tokens. So it's gonna be buy tokens. Yeah. Color amount sent. Amount stored amount equals to times to stop. All right. So Yeah, basically. Is there any question? Does anyone have any question? Anybody here? Is there any question?
No, for now.
Okay. So what we are going to do here is basically the opposite of the buy tokens. Let's see, assets. It is also this event transfer that set dot event transfer that that's a minute more. I'll start to use completion in some cases. So you can get to the end of this. So the rate, let's rate. What is set dot rate dot read. Set your address. Let's contract balance. Let's show token contract equals dispatcher. Set token contract and contract balance. Contract balance equals set token contract that balance of contract that is which contracts. So we need to assert send question. Do you understand this logic? So we are converting back to the amount that they are buying, that they bought, instead of now multiplying with divide. So if they use 1 to buy 100 here, and they want to sell and they sell 100, so instead of that, we do 100 all over 100, which is going to give us 1, right? Is that understood? That's that. Contract balance is equals to change. So transfer token to the user. No, transfer token to the contract. The contracts. Sell token dot transfer from color to this contract. No, not amount to send. That. And then payment to send, transfer token to like tokens. Yep. We do not have set tokens current constructor and still token. Okay. Is there still anyone in this call? Okay, good. All right, so we want to separate now. For us to separate, we also want it to be only the owner that is able to separate. Assert only owner. The rate must be greater than 0, and we should write the storage, then we should emit an event. Let's rate serve dot read. Yeah, this is how we can now create a new rate. We also need another event. Derive, yeah, it's set. Trying to move as fast as possible. Okay, new rate. Yep. So get to it. This is basically just self dot read, get tokens out. Yep. This is also what we're going to happen here. Then withdraw payment token. For the withdraw payment token, only the owner should be able to withdraw. Only the owner should be able to withdraw. That is certain. Let's buy open contracts because we have security, disperser, buy token dot read. Yeah, this contract. This contract balance of this balance not be greater than 0. Yep. Do you understand this part? So the caller address, since we have already asserted that this should only be called by the owner. So if this function is called by somebody else that is not the owner, it is definitely going to fail. But once it fails, we also want to still do another two-factor authentication here. So this transfer will only go to the address of the caller, nothing else. So let's also emit an event. Self.emit event. Okay, we're done. And then token withdrawn. I can do basically just do the same thing for this one. There are a lot of optimizations that can be done to this contract, but I will leave that to you because some of these are functions integration we are doing here. they can be abstracted into an internal function. But for the sake of time, we will not be diving into that. So maybe your assignment will be to look at this contract, and then if there's any logic that we are repeating over and over and over again, you can definitely just abstract it into an internal function and then call them in the body of this function. This is similar to what I'm talking about. Where is it again? From the row. This is a contract that is in production. We'll start creating it. So you will notice that we have internal functions here. So these internal functions are functions that we can use inside our core logic. So probably the number of times we want to calculate protocol fee, there are several places where we call protocol fee. So we do the calculation. Instead of repeating the logic everywhere, we just call the internal function. I hope that is understood. So we do our payment token. So what we need to do is also make sure that only the owner can call it. We do that separately. Basically everything here. Balance to withdraw. Say save dot token. Nothing like token at read. This contract. Balance of this, and open that. Also transfer contract balance. You notice the difference here is that we are removing everything that is here. Contract balance. The contract balance instead of passing an amount. So here, everything that is inside the contract will be withdrawn. The opposite is the case for this one. Withdraw share token. So here we do the safe token part. And certainly for now, then we do the sale token, we do all of the sale tokens here. The only thing we need to modify here is the event. Event. Have two events to modify payment token withdrawn and sale token withdrawn. Payment token withdrawn and sale token withdrawn. So now we also need to add them here. Payment token, the event, sale token, buy token, never payment token withdrawn, sale token withdrawn. Yep. That's basically all we need for this contract. Let's build. So you will go from here. Okay, identifier not found. Just online. Okay. Line 146. Line 146 here. It should be 7. Line 157. 157. Yeah, we did not initialize the buy token. Let's buy token contract equals to this. And then yeah, I think we have the family two errors. Awesome. So we have that done, presumably. Now we need the two tokens that we need for our our exchanges. We also leverage components here because we are going to build on top of the pre-existing ERC20 component, as we mentioned earlier in the call. So we started here. We have components. We have interface rather. UI interface. English techniques. Interface. Techniques. Interface. Interface. Objects. Looking here. Equals the function. Needs. Yep. That's everything we need here. Then for our contracts. Yeah. Okay. For our contract node, working here equals to the import. We need storage here. We need to use document. Get color address. Get color address. Yeah. And then we need to bring our enable as well as ERC20 into scope. ERC20 use the enable component and use open Zeppelin. Okay. ERC20. ERC20 component. ERC20. ERC20 component. And ERC20 component. As well as this particular truth. ERC20 component. It's empty implementation. Yeah, this is it. ERC20 puts empty implementation. It's only looking for ERC20 puts empty implementation. So we have the two things we need to have translate left. So our storage, let's do component initialization as we did the other time. Enable component, ERC20, sub storage.
Sorry, sir, your screen is not displaying.
Oh, really?
Yeah, it's just your face, just your camera.
Is that show for everybody else? Because I can still share my screen.
It's displaying for me.
That's what I'm wondering, because I can still see it here. So I will just proceed since it is not general. Let's do the same thing for sub storage version 0, ERC20 storage. Then the event. we have the ARC20, right? This is similar to what we have done so far in the, just trying to bring all of this into scope. So how we need here is just constructor. We are embed, implement token here, of I token here. This is only one here, also 20 documents. Is this understood, or do I need to explain? It's similar to what we have done so far here with the components, with bringing components into scope. Let's complete it. And then use to okay, we should set the name of this token. So set the name of the token, we use format. Format, we see that format token here, format token B. So token here, let's just call it USDC. 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 Right. The same thing with that what we do for token B. All we just need to do is just copy from token A and change some of the integration and token B. This one is token B, and token B implementation of this. This is going to be Netflix lab. BFS, I'm going to comment it too. And run. Step on translate, just to be sure not missing. Let's build, start build. Okay, so sometimes it shows function needs. Like this. Oh, okay. Well, in that case, I can contrast it. Contrast it. Contrast it. Yeah, it's back. And see, let us know. optimize. So taking care of the also sequence updates. Oh shit. Okay. So which other thing? Constructor is it's this should get completed with okay, so this needs the element okay. Okay, so and then where else again? Matter. I think it's using this thing that just okay, that's from the first. Event not found. Yes, it is event. Yes. Do you want to enter it? Speak of the event. Event. It's good. Yes. Yeah. Then taking this, contract address. Okay, viewing. Okay. Use the current contract address and the technology. Instructor. It is not there. Not Okay. Good. Awesome. So yeah, everything works perfectly fine at the moment. So this is the last lap of our testing. So we need to deploy the two tokens and deploy the token share contract and test in production to see if everything works. So cast like parent and then I come to there, I can do here and try to name. Work, look, here and try to name. The contract name is token A. So let's see first. Hmm. Okay. So we have the contract for token A deployed. It's already, sorry, we have the class hash deployed. It's already on Sepolia. So now we need to deploy the class hash. So if you notice in this argument here, it is already telling us what to do to deploy that. So here we only need to modify this owner and actually update it to the live address with the owner of this contract. Let's go here and use a live address that we can test in production with. Okay, so here, let's use this. Let's use this. So we replace this with an address and deploy. Awesome. So our contract is deployed and it is here. Now while that is going on, let us deploy token B. Let's deploy token B. We have the token B. Oops. Make it fast. And copy. Here. That's the token B. Right. So, okay, so now we have the open A contract here. And read contract. And you can write contract. Oh, right. I believe there is a mistake here. And the mistake is here. Implement. Yeah, ERC20 implementation of ERC20 implementation. Yep. So we did not expose all the public function of ERC20. We only exposed that of the ownership component. So if we come back to the code here, right, that's it, and that's it here. Yeah, all of this code, ERC20 implementation. So we need to redeploy. I need to redeploy taken here. Let me try something. Yeah, okay, deploy token cell. Deploy token cell. Alright, so let's do alright, alright. Let's do So is anyone to follow you? So want to correct one of the mistakes made earlier. It should be done. It should be true now. Right. Ah, this is something that we are going to spend 3 hours. Like this. This one. Into practice. Valid transaction nodes. Oops. Right. And why is that one valid transaction nodes? So we have both of them currently deployed. So now we need to deploy our token sales. For our token sales, where is the constructor? We need the owner of the contract. It's being deployed already in the class search. It's being deployed. So we need here is this. Yes. Now back to this. The contract matrix. It should be what you can do. Okay. Uh, it's good. It's good. Let me go to the toilet. I need to just it's myself. Yeah, so I'm back. Let's continue. So, okay. So every of these are extendable, like public function that we want to expose needs to be annotated with this. Otherwise, the contract we assume is an internal function like these two. So that's why we've been struggling with getting That's why I've been struggling with getting the ELC current implementation. No, I'll switch this to USB-C. 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 So this one will switch to block 6 now. And let's see that looks. We'll change this to block 6 now. Okay. Change this to block 6 laptop. And we'll change this to block 6 laptop. So it should be it for this one. This implementation, it doesn't matter. We're just to show. All right. So need to get it right. This one is USB-C. Just to clear. Field to find like now and start not with it. This is something. Let's go to the end. Right, it's anything different. And also this is next. I'm just finding this is something the artifacts, but okay, Starknet. Okay. There's something I'm missing. So, I wonder. Oh boy. Basically, code will frustrate you. So it is just a letter misplaced that has been causing me that headache. Oh, alright. So, So this is for the peer. All right, so that is exactly what we want for the form. So this one we want to do. There's a replicate here. It contacted her. Now we have what we are looking for. Can we also have that one here? Okay. Okay. Right. Okay. So now we want to this is the token. Let me mimic one user that wants to buy the token. Copy this person's address. Let me copy this. Up to this. Into then into 7. Okay. C3. Yes. So this is the token that they are going to be buying with. Let's mint. Let's mint 1,000 units to this particular address. So the 1,000 units is going to be 1, 2, 3, then 18 decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we transact. Okay, so let's confirm the argument. We assume that we have minted 1,000 units of USDC to this account. So let's check the account balance. The balance of this account. So, monetary response. Response. Decimal, yep. So here is it. Here is the current balance of this new address. Is anybody still following me? I thought I'm here. It's been long, guys. I know. 3 hours. It is not. You think live coding is just something that should be straightforward. But then you spend a lot of time debugging minor issues here and there. So we have minted for the person who is going to buy. Now we also need to mint the token that we are selling for the contract. So the contract, we also have a balance of the token. So here is the contract that is actually, here is the contract that we are going to be interacting with. So we also need to have some tokens minted to hit. This is the block shoe snap token that we are selling. So we mint it to the contract. And then we give the contract maybe 100,000, 10,000, 1, 2, 3, 4, this is 10,000. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right. So we mint. Once we check the balance of our contract, it should have the total amount of work we just needed to it. So yes, it has that balance now. So the next thing to do is for the buyer to approve our contract to spend from their balance. So we make the buyer. Don't forget that the buyer is this other wallet. This other wallet. Yeah, this is the buyer. So the buyer must approve our contract to spend. Must approve our contract to spend. Who is the spender? The contract. How much do they want us to spend? They have 1,000 USDC. So they want to buy 100 USDC worth of our token. So they should allow our token to spend, let's say 101 in case of any handling error. 101, 101 unit of their token. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 decimal points. And then we transact. So this is basically approving. So the approval is successful. And once that is done, they can go to our contracts and then click buy. So they want to now buy token now. Initially, we want to know how much token that their 100 USD will buy. So if they put in the 100, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So they want to know how much they will be able to get. I hope we have not made any mistakes, so we get token out. Oh, okay. Yeah, here is the problem. We have not initialized this particular contract. So initialization is important before anything can function well. So we need to initialize it. So this is the address of the token they are going to use to buy. We need it here. This is the address of the token we are selling. Put that here too. Okay. So what is the rate? The rate is 100 per one. So we are going to send 100 as the rate. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. You see, there will be an error here. And what will be the error? This account that is currently trying to call our contract is not the owner. Let me visualize that so you see the error. Yeah. So this is what the error is telling us. If we copy the error message, go to our code editor, it is going to tell you what caller is not the owner. So the caller has to be the owner of the account. That is the reusable component of ownable that we brought into scope. That is one of the expected results. So yeah, we are seeing ownable in action, our advanced component in action. So, let me give me a few seconds. Yeah, sorry. All right, so let me continue. So we switch the wallet to the wallet of the owner, which is the wallet one. And then we call this function again. So it's been initialized. And so we go back, if we go back and call that function to get so this function. If we go back to call the function, we get token out. We should, you know, it's initially 0 here. We should have the new value now. So this is the new value that we are supposed to be getting. So it's no longer 0. Oh, wait. Interesting. Let me get to it again. Okay, so this is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yep. So the rate is 100. So when you accurately format this, it should also be a round figure, because I believe, okay, let's even use a one, two, and anybody let them in. Somebody's trying to join. Okay. So let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this is on good. That's what you want to use one to buy. Okay. So this is more of it. So if they are buying with one USDC, they should be getting hundreds of our token back in value. So what are they doing here? They want to now buy the actual amount. So once they want to buy the token, forget, we need to switch back to the wallet of the user. All of this is because we have not gone to the part where we can actually test our contracts programmatically. The next class will be handling that, so we do not need to be switching all of this, switching interface. Everything will be done with code inside our editor. So we can always verify that this is going to work the way it should before even deploying at all. So buy tokens. How much token are we buying? We are buying token worth of 10 USDC. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So now tokens. Sufficient. 152 sufficient balance. Yes. Thanks, people. I'm on a call. I should say. Sufficient amount. More my token. One second. All right, let me check. Check the right second. Insufficient allowance. How much is the allowed for contrast to spend? Oh. I think this is not totally. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. The comments. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. This is more than enough allowance. Why is it showing insufficient allowance? Enough allowance. So here. What is this? Yep. This is correct. Identify. Oh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. You need to wonder. There is sufficient balance. Sufficient balance. Four, five, six, seven, 8, 9, 10, 11, 12. Okay, of course. Three. Very good, sir. Yeah. Okay, good. Mhm. Oh, oh. All right. Anyone want to hear?
Yes, sir.
Thank you for staying with me. Yeah, there's a bit of confusion in the code. I don't know where the error is coming from. Uh, Sometimes it requires stepping away from the code. Code is quiet. Yeah, 1,000. Yeah, 1,000. 1,000. I can see what the problem is. So for one-word reasons, right? The tokens we are minting to the contracts is not actually sending to it. So that is where the problem lies at the moment. Meanwhile, the tokens we minted to the user are reflecting. So here is it. The token we minted to the user is reflecting. If we come here again and do we mint, to Okay, guys, I think we'll round up here. So on Monday, when we are going through the testing, we'll go through the debugging and we'll see what the issue is at the moment. At the moment, everything seems to be working fine because yeah, look at the event emitted. It is correct. Like here, the value sent. So this is the value minted to this person from account 0. We check balance of balance of market. Check balance of this. And the balance of this. Excellent. So where is the color from? If the contractor defined Yeah, so basically, what we have been able to do so far is bring the components into play, and you've all seen how those components are working together. The current issue we are trying to debug is not a major one, so if the code is left for a few minutes, that's my style of debugging most times. When you are going through something, you leave it for a while, you come back and you see where it is not a matter of code is correct, something is wrong upon deployment. But one of the things that this will protect us against, I just don't want to jump the gun, is the fact that before we even deploy, we can actually test in our local environment programmatically. So if it works there, the assumption is going to be that it definitely is going to work upon deployment. So on Monday, we'll be diving into the testing. So we will use the same contracts so that we'll actually see where we could be wrong at the moment and why our contract is not, the buy contract is not behaving the way we want it to behave at the moment. So thank you guys for joining. I will be jumping off here to take care of some other issues and hope to see you guys on Monday.